Let's look at another initial value problem. So we're given that the derivative of y, dy dx, this is equal to 1 all over 2 square roots of x. We're also given that the original function y, when evaluated at 4, when x is 4, that value we get back is 0. And so we want to find our original function y sub x. And so we can take the antiderivative of the derivative to get that original function. And we saw that we could set this up as an indefinite integral. And so looking at this, we know that y is going to equal the integral of, well, before we write this in the integrand, let's rewrite this so that it's in square root has an exponent instead of the radical. And let's bring it up into the numerator because that makes it so much easier for us to find that antiderivative. And so let's rewrite it. We have this 1/2 coefficient, and we know that 1 over square root of x, that's the same thing as 1 over x to the 1/2 power. Bring it up into the numerator, so this would be x to the negative 1/2 power. So x to the negative 1/2 power dx. So recall, and we just talked about antiderivatives, if you're looking at the antiderivative of x raised to some power n dx, what we did was, so again, the antiderivative is what we could take the derivative of to get back, in this case, this integrand x to the n. Remember, when we're taking derivatives, we bring our power down and we subtract 1 from our exponent. And so knowing that we subtract 1 from our exponent and we want to get back in, we actually add 1 to our exponent. Well, if I took the derivative right now, I would have an n plus 1 in front of this x, and subtract 1 from the exponent, I would be good because that would give me back this right here. So to compensate, because we don't want an n plus 1 in front of this x here, we're going to divide by our new exponent. And we always added c when we had an indefinite integral, and we'll talk about definite integrals later, where we don't have to worry about adding that c value. So remembering this, let's now take the antiderivative of 1/2 x to the negative 1/2. So we don't have to worry about the coefficient. We leave it alone, 1/2. Now taking the antiderivative of this, we're going to add 1 to the exponent. So negative 1/2 plus 2/2. That gives me back a positive 1/2. And then I'm going to divide by my new exponent, which is 1/2. And then we need to add our c. And this is what our original function of y is equal to. Almost. We need to know what that c is. So let's clean this up a little bit before we go in and plug in what we know to find c. This is the same thing as y is equal to 1/2. Well, dividing by a fraction. So we can rewrite that as a multiplication problem. So we're inverting the denominator and multiplying. So inverting this 1/2 gives us times 2 over 1. I'm just going to put it in front, just because these are my coefficients. And then x to the 1/2 power, which is the same thing, right, as the square root of x plus c. So our 2's cancel. Nice. And we get y is equal to the square root of x plus c. So let's go in and plug in what we have. So we know that y is, when x is 4, y is 0. So we get 0 is equal to the square root of 4 plus c. So we get 0 is equal to 2 plus c. We can get c by itself by subtracting 2, so we get c is negative 2. So knowing what our c value is, knowing what our original function was, with the c in there without knowing the c. It was y is equal to the square root of x plus c, so minus 2.